A question is given followed by two statements 1 and 2. Consider the question and the statements and mark the correct option. And so initially I thought it will be like data sufficiency. So using one statement, using two statements, using one but not the other, etc., etc. It is very much like that, but with a mild twist. And so what is the smallest one-digit number having exactly 4 distinct factors? And I read this question. There are two statements. 2 is one of the factors, 3 is one of the factors. We have to pause and say, look for the smallest single digit number having exactly 4 distinct factors. 6 has factors 1, 2, 3, 6. 4 distinct factors should be a product of 2 distinct primes. The smallest one is 2 into 3, done. I was a little surprised at seeing the question. And you go to the choices, it says the question can be answered by using one of the statements alone, but cannot be answered using the other statement alone. Question can be answered by using either statement alone, can be answered by using both the statements together, but not by either one alone. One alone, but not the other, either one alone, nothing alone, but both put together. The question can be answered even without using any of the statements. This is a slightly wacky choice, and that's our right answer. When the smallest single digit number having exactly 4 distinct factors is 6. So typically when we ask for smallest or largest, then we have some context already. And so for that context, the smallest we should be able to find it. And unless there are something really murky, they should automatically give us a unique answer. So the question can be answered without anything from here. And so answer choice D for delta. And so in data sufficiency, typically at least one statement is needed. This type of data sufficiency has a choice which says, look, we don't even need either statement. You read the question, you can give the answer. And that's the right answer this time around. The smallest single digit number is 6. R has be distinct non-zero digits if PP into PQ is RRSS, where P is less than or equal to 3 and Q is less than or equal to 4. And what is digit Q equal to? Statement 1 R equal to 1, statement 2 S equal to 2, and then we have choices. Using either statement alone, one alone but not the other, both together, and can be answered without using any of the statements. So PP into PQ equals RRSS. First thing we notice, PP is a multiple of 11. 11, 22, 33, 44, one of those. RRSS is also a multiple of 11. Right, so 111 we can cancel, get it out of the window, get it out of the place. Right, so PP by 11 is P into 11 into PQ, RRSS divided by 11. So let's do this. RRSS divided by 11. You go R times RR, get an S down, 0. So P into 11 into PQ is 11 into R0S. I'm writing it with a slash so that we don't think of it as ROS. Okay. So 11 gets cancelled, and quite beautifully we have P into PQ is R0S. Nice. We know P is less than or equal to 3, Q is less than or equal to 4. P is less than or equal to 3, P can be 1, 2 or 3. And so it's a super starting point. And so I'm going to start with that. And so 1 into 1 something cannot be a 2-digit number, 3-digit number. 2 into 2 something cannot really be a 3-digit number. 2 into 29 is also only 58. 3 into 3 something. This could potentially be a 3-digit number. 3 into 33 is 99, but 3 into 34 is 102. 3 into 35 is 105. 3 into 36 is 108. There are possibilities. And so straight away we could have 3 into 34 equal to 102. 3 into 35 equals 105. 3 into 36 equals 108. We don't worry about P being more than 3 because P is less than or equal to 3. 1 and 2 don't work. P has to be 3. Right? So these are 3 possibilities, but Q is less than or equal to 4. P into PQ. So these two are out. So 3 into 34 equals 102 is not just a solution, it is the only solution. Right? So what is Q equal to? Q is equal to 4. We don't need this, we don't need this. The question can be answered even without using either statement. How is Q related to P? P has two sisters R and S. This gives us nothing. P has two sisters R and S. There's no Q. Right? R's father is the brother of Q. This links something between R and Q. There's no P in this. So first thing we notice, to answer this question, we don't have anything sitting in the question itself. So it cannot be answered without the statements. This is not enough. This is not enough. So now we say, hey, maybe we put both of these together and then see where it is going. Right? So statement cannot be answered without the two statements. Question cannot be answered without the two statements. We need the two statements. One alone is not enough. Two alone is not enough. We have to put both together and answer this question. Right? So if you look at the choices, can be answered by using one of the statements alone. Cannot be answered using the other statement alone. This is out. Can be answered by using either statement alone. This is out. Can be answered by using both together, but cannot be answered by using either alone. Maybe this is still in. The question can be answered even without using, no. So A, B and D are out. C is a possibility. So if there's a gun onto the head, we are under pressure, we mark C and get out of it. But let's solve this. Right? So P has two sisters R and S. P, R, S, same generation. R and S are sisters. So they're girl, they're siblings. R's father is the brother of Q. So one generation higher. R's father and Q. R's father is obviously boy, male, brother of Q. Q could be male or female. Right? How is Q related to P? Q is P's aunt or uncle, right? Father's sibling. Right? Technically speaking, if I had been given this question, there were a choice which said using both statements, we still cannot answer the question. I would have been tempted to mark that because we are reaching the point where we say Q is P's aunt / uncle. Right? So we cannot point out whether it is aunt or uncle. Luckily enough, in this question, that choice is not there. So with a hard heart, slightly aggrieved feeling, I'll mark C. In a football match, Team P playing against Q was behind by 3 goals with 10 minutes remaining. Thus, Team P win the match. Straight away, just reading this, we cannot answer the question. They were behind by 3 goals with 10 minutes remaining. Could they have won the match? I don't know. Maybe they did, maybe they didn't. Right? Team P scored 4 goals in the last 10 minutes. Is that enough? I don't know. Team P scored 4 goals in the last 10 minutes. Maybe Team Q scored 6 goals in the last 10 minutes. So I don't know. Statement 1 standalone, not sufficient. Team Q scored a total of 4 goals in the match. Team P playing against Q was behind by 3 goals with 10 minutes remaining. Q scored total of 4 goals in the match. P could have scored only 1 or even 0 technically. This could have been in the last 10 minutes, or they could have scored 10. Standalone is not sufficient. And so question alone is not enough. First statement alone is not enough. Second statement alone is not enough. Those are the easy inferences. Right? Now we have to put both together. And so Team P playing against Q was behind by 3 goals with 10 minutes remaining. Thus Team P win the match. Team P scored 4 goals in the last 10 minutes. Team Q scored a total of 4 goals in the match. They were behind by 3 goals. So they scored 4 goals in the last 10 minutes. It's very much possible that they won the match. Right? So with 10 minutes to go, we could have had PQ being 1-4. Q scored 4 goals totally. P is behind by 3 goals. All good. And then P scores 4 goals in the last 10 minutes. Q doesn't score anything. P wins 5-4. It's a possibility. Okay. Second possibility, if we can have a scenario where P does not win the match, then we can say it's not sufficient. Okay. So 10 minutes to go. And final. Q scores 4 goals. is there a possibility that P scored fewer than 4? Not possible. Scored 4 goals in the last 10 minutes. P could not have lost. So might they have kind of drawn this match? We'll think about it. Final score being 4-4. 10 minutes to go, PQ being 0-3. Very much possible. The last 10 minutes, P scores 4 goals, Q scores 1. And before that it is 0-3. So finally they end with 4-4. So P could have ended up having a draw with Q. P could have ended up defeating Q. So both of these are possibilities. And so does team P win the match? We don't know. So the question can be answered using one of the statements alone, cannot be answered using the other statement alone. No. Either statement alone. No. Can be answered by both statements together, but cannot be answered using either statement alone. No. Can be answered even without any statement. No. The right answer choice is E, that the question cannot be answered even after accounting for everything, even after taking both statements into account. From an exam point of view, what do? We pray and we either gamble or leave this question. If I were gambling, I would put C. The other three seem to be obviously wrong. C at least will least bad among very bad choices. Is P plus Q the whole square minus 4 PQ, where P, Q are natural numbers? Positive. Right. Very interesting question. P plus Q whole square minus 4 PQ. P plus Q whole square is P square plus Q square plus 2 PQ minus 4 PQ. This expression become P square plus Q square plus 2 PQ minus 4 PQ, which is P square plus Q square minus 2 PQ, which is P minus Q whole square. Is this positive? It's a nice perfect square. It cannot be negative. Therefore, it is positive, except we cannot say it is positive because it could go to 0. Right? So I can say P minus Q whole square is greater than or equal to 0. It will be 0 when P is equal to Q. It will be positive when P and Q are different, not equal. Right? Now we've made that inference. So question can it be answered just from the question? No. We don't know whether P is equal to Q. If P were equal to Q, then this won't be positive. It will be 0. If P and Q were distinct, then it will work. Statement 1, P less than Q. Yeah, if P is less than Q, it will be positive. So statement 1 standalone is sufficient. Statement 2, P greater than Q. Statement 2 standalone is sufficient. 1 alone is sufficient. 2 alone is sufficient. The question can be answered using either statement alone. In a T20 cricket match, 3 players X, Y and Z scored a total of 37 runs. The ratio of the number of runs scored by X to the number of runs scored by Y is equal to the number of runs scored by Y to the number of runs scored by Z. And so X is to Y equals Y is to Z. Or in other words, X, Y, Z are in a geometric progression. AR square. Nice. Value 1 is runs scored by X, value 2 is runs scored by Y, value 3 is runs scored by Z. Can we find these values? Yeah, we can try, because the total is 37, we're dealing with integers. But let's look at the choices. Value 1 less than value 2 less than value 3, geometric progression. Value 3 less than value 2 less than value 1. Value 1 less than value 3 less than value 2. Cannot be determined due to insufficient data. Very interesting. And so geometric progression 1, 4, 16, 2, 6, 12, right? AR square. But the very interesting thing about geometric progression is, suppose we have 1, 4, 16, we could have 16, 4, 1. If we have 2, 6, 12, sorry, 2, 6, 18, 2 into 3, 6, 6 into 3, 18, we have 18, 6, 2. If a sequence like this is a geometric progression, like this also is a geometric, you reverse a geometric progression, you'll get a geometric progression. So value 1 less than 2 less than 3 is possible. 3 less than 2 less than 1 is also possible. So this is the right answer. And an interesting question. We don't need to find the values. Right? So the values, as it turns out here, are 9, 12, 16. Add these 3, we get 37. both ways it will work. 16, 12, 9, 9, 12, 16, both ways it will work. We don't need to find this. Just the understanding that x, y, z, if you flip the value, put x as z, z as x, all the conditions will be satisfied. Therefore, let p plus q equal to 10 where p and q are integers. Maximum value of p into q where p and q are positive integers. Very nice. They're positive integers. Sum of them is, so add these two, you get 10. Positive integers, it will be 1 plus 9, 2 plus 8, etc. etc. 5 plus 5, 10, 5 into 5, 25. That will be the answer. Value 1 is 25. Maximum value of p into q where p is greater than or equal to minus 6, q is greater than or equal to minus 4. Could be, that means one of them can be negative. But remember, if we are talking about maximum value of p into q, that p into q will be positive when both are positive or both are negative. Both cannot be negative. Therefore, both have to be positive. Fine. Otherwise, we will get a negative term. So, if both positive is possible, then we should not do one positive, one negative. Right? So the maximum value of p into q where p is greater than or equal to minus 6, q is greater than or equal to minus 4 will again revert to just being maximum value of p into q when p and q are both positive. We cannot have a scenario where one is positive, one is negative. Then their product will become negative, that won't come. We cannot have a scenario where both are negative, then this won't be satisfied. If you are looking to find maximum value of PQ, automatically P and Q have to be positive, which means this answer and this answer will be both same and equal to 25, value 1 equal to value 2. Consider a set of 11 numbers. Value 1, minimum value of the average of the numbers of the set when they are consecutive integers greater than or equal to minus 5. Average, so we want all the numbers to be as small as possible. Consecutive numbers greater than or equal to minus 5, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. It's the best combination. Minus 5 to minus 1, plus 1 to plus 5, 0. Best combination, in which case the average will be 0. Add all these numbers, we will get 0. Minus 5 and plus 5 will get cancelled. Minus 4 and plus 4 will get cancelled. We will get 0. Super. So, value 1 is 0. Value 2, minimum value of the product of the numbers of the set when they are consecutive non-negative integers. Non-negative, so starting with 1, minimum value of product, all numbers should be as low as possible because we are dealing with positive integers. 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11. That's the best possibility. It is a large number. I don't need to find the number. I know this is large positive number. Value 1 is less than value 2. Let x be a real number between 0 and 1. Which of the following statements are correct? X square greater than x cube. Super important funda. This is true. Super important funda. We are conditioned to think x square, x cube, x power 4, they get bigger and bigger. When a number is between 0 and 1, higher powers become smaller. And so, if you have half square, half cube, half power 4. This is 1 by 2, 1 by 4, 1 by 8, 1 by 16. They keep shrinking. Fine. So, the higher powers become smaller. Fine. So, half of half, less than half. Half of that, less than that. Fine. So, x square greater than x cube, that is definitely true. Not just for half, any number. 1/3, 1 by 9, 1 by 27. 2 by 3, 4 by 9 goes smaller and smaller. Any number multiplied by itself will become smaller if the number is between 0 and 1. Okay. X greater than root x. Here, x is the higher power. This won't be true. 1 by 2 and 1 by root 2. 1 by 2 and root 2 by 2. 1 by 2 is half, root 2 by 2 is more than half. So, x is greater than root x. No. Same funda. Square root of x will be a larger number. Root x into root x has to become x. And so, beautiful idea. When the number is between 0 and 1, higher powers are smaller. Smaller powers are larger. Statement 1 is true, 2 is not true. What comes at x and y respectively in the following sequence? January, December, October. it goes backwards. Right? So if you have to, sometimes you have to write it down. So I'm going to write it down. Jan, Feb, March, April, May, June, July, August, September, October, November, December, maybe January again, just for continuity. Jan, December, October, X. Jan, no gap. December, 1 month forward. October, 2 months forward. Next step will be July. Jan, December, 1 skipped, 2 skipped. September and August skipped, we go to July. 3 skipped. June, May, April skipped, we go to March. From July to March, yes, that works. So X can be July. From March, we skip 4 months, go to the 5th month before. 1, 2, 3, 4 skipped. We go to October. Nice. From here, we have to skip 5. 1, 2, 3, 4, 5 skipped. We go to April. April should be Y. We are going to skip 6. 1, 2, 3, 4, 5, 6. And we go to September. Yes, that works. So we're going reverse, skipping 0, skipping 1, skipping 2, skipping 3, skipping 4, skipping 5, skipping 6. So X is July, Y is April. X and Y respectively July and April. That's it. If 7 asterisk 24 is 25, 12 asterisk 16 is 20, what is 16 asterisk 63? And so very interesting. 7, 24, 25. It's a Pythagorean triplet. 7 square plus 24 square is 25 square. I just know this. Fine. So if you don't know this, it's tough. 12, 16, 20. 3, 4, 5. 3 square plus 4 square is 5 square. And so 12 square plus 16 square is 20 square. All we need to do 16, 63, what else? So 16 square plus 63 square is what square? So, or 16 square is x square minus 63 square. X plus 63 into x minus 63. So it's 70 plus 63, 70 minus 63. No, 70 minus 63 is 7. 16 square has only 2's. 66 plus 63 is 129. No chance. 65 plus 63 is 128. 65 minus 63 is 2. 128 into 2 is 256. Consider the following statements. A is less than or equal to B, greater than C, less than D, greater than E, greater than F, greater than or equal to G, equal to H. Then B is always greater than E. Let's take B to E, just a sequence. B is greater than C, less than D, greater than E. B is always greater than E. Is that possible? I'm going to put some numbers. Let's put it as 5, 4. And then D is higher. I'll put it as 100, 99. B is greater than E, not necessary. The moment something flips like this, then the thread need not be maintained. So all we need to think is like a counter example. Right? So this doesn't work. P is greater than Q, equal to R, greater than S, equal to T, less than or equal to U, equal to V. Then S is always less than V. S to V, S equal to T, less than or equal to U, equal to V. S is always less than V. No, we could have 5, 5, 5, 5. S could be equal to V. So this also need not be true. Neither 1 nor 2. Consider the sequence A, B, dash, C, C, dash, A, dash, B, C, 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 dash, B, B, C, dash, C. It is A, B, dash, C, C, dash. Just try different things. A, B, A, C, C, dash. I don't know. A, B, A, C, C, dash doesn't work. A, B, B, C, 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 A, B, B, C, 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 A, B, B, C, C, C works brilliantly. A, B, B, C, 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 A, B, B, C, 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 A, B, B, C, 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 B, C, B, A, C works. B, C, B, A, C, done. If P equal to plus, Q equal to minus, R equal to product, S is division, then insert the proper notations between successive numbers. It's kind of trial and error. We need to remember our BODMAS rules. So, two of these start with Q, two of these start with S. QR, SP, QR, PS, SP, RQ. So, the starting here are SP, here are QR. I'm going to go with that. And so, let's say SP 60 divided by 15 plus 3. 60 divided by 15 is 4. 4 plus 3 something. Fine. SPRQ. R is into 20. Q is minus 4. 3 into 20 is 60. 60 divided by 15 is 4. 4 plus 60 minus 4. Doesn't work. And so SPQR we can come to. I'm going to try QRPS. Right? QRPS 60 R is into, sorry, into Q, sorry, Q is minus 60 minus 15, R is into 3, then 20 and 4, P is plus 20 divided by 4. 15 into 3 is 40, 20 divided by 4 is 5, 15 into 3 is 45, minus 45 plus 5. 15 plus 5 equal to 20. We got lucky. This one works. QRPS, nothing but trial and error. Without choices, these questions become very tough. With choices, much easier. 3 teams PQR participated in a tournament in which the teams play with one another exactly once. A win fetches the team 2 points, draw 1 point, 0 points for a loss. Each team scored exactly 1 goal in the tournament. Only 1 goal they've scored. Team P got 3 points, Q got 2 points, and R got 1 point. Team P got 3 points. That means they won 1 game and drew a game. They scored only 1 goal. And so that means P should have had a 1-0 and a 0-0. 1 win, 1 loss. Q got 2 points. 2 points can be 1 win, 1 loss, or 2 draws. Right? So P has 1 win and 1 draw. Q could have had 1 win and 1 loss, or 2 draws. 2 possibilities. I'm going to come back to Q later on. I'm going to go to R. R got 1 point. So 1 draw, 1 loss. Right? So scored only 1 goal, 1 draw, and 1 loss. The match that he lost, he couldn't have scored 1 goal. That is 0. So lost 0-1 and drew 1-1. Nice, brilliant. So scored 1 goal, conceded 2 goals, drew this match, lost this match. Right. So P has 1 win, 1 draw. R has 1 draw, 1 loss. Q could not have had 1 win, 1 loss. Who could have been won against and lost against? Then P and R would have had to have a draw. This is 0-0, that is 1-1, not possible. Q should have had 2 draws. Q had 0-0 and 1-1, draw plus draw. Now it's very easy to match. So P versus Q, P won against R, 1-0, 0-1. PR ends 1-0. PQ ends 0-0. QR ends 1-1. P won against R, drew with Q. Q true with R. Yeah, true. The result of the match between P and Q is a draw with the score 0-0. Yes, that is true. The number of scores scored by R against Q is 1. R against Q is 1. This is also true. Which of the following statements is R correct? Both are correct. 1 and 2. Choice C. 1 and 2. Both are correct. P is the brother of Q and R. S is R's mother. P is the brother of Q and R. So P, Q, R, same generation. P is the brother. So P is a boy. S is R's mother. One generation high. Mother, so girl. T is P's father. These three are siblings. T is the father. So these two are a couple. T is a boy. How many of the following statements are definitely true? Right? S and T are a couple. Yes, they are. Q is T's son. No, no, no. Q could be T's daughter. Not sure. T is Q's father. Yes. S is P's mother. Yes. R is T's daughter. No, no, no. R could be T's son. P is S's son. Yes. So how many of the following statements are definitely true? 1, 2, 3, 4. 4 are true. If no is coded as 210, not is coded as 4200, note is coded as 21000, then how is notes coded? No, not becomes bigger. NOT becomes even bigger. NOT, as the numbers are getting bigger. And so NO to NOT, NOTE. This is 210. This is 4200, 21000. Numbers are getting larger, dramatically larger. Almost like I'm not just adding something, I'm multiplying. And 210, 42,000. I mean 4,200. This into 20 into 5. Very interesting, because this just makes it fall in place. When we have A, B, C, D, E written down, E is 5, fifth letter. And so E is the fifth letter, J is the 10th letter, O is the 15th letter, P, Q, R, S, T. T is the 20th letter. Brilliant. Therefore, I'm adding E multiplying by 5. I'm adding T multiplying by 20. I'm adding S, N-O-T-E-S, notes. S is just before T. If T is 20, S is 19. So we're looking at 21,000 into 19. 0, 0, 0. 19 ones are 19. 399,000. Yes, that's there. That's all right. If France is coded as 654321 and Germany is coded as 9158437. And so 7 letters, 7 digits, 6 letters, 6 digits, quite possibly each digit is matched to one thing. France is this. Between France and Germany, E, A, R are common. And so let's look at R. R is 5. R is 5. Yeah, that works. Brilliant. So E is 1. E is 1. That's brilliant. So letter by letter we can get it. Yemen, we have 2 E's. E is 1. Y, E, M, E, N. We're looking for an answer choice, which is this one, this is 1. This is out. But hey, we still have multiple possibilities. Right? What can we infer? We can get M and N. What is M equal to? 2, 3, 4, 9, 1, 7, 8. This is 8. N also we can get, but with 1, 8, 1 only. Let's get N also. N is 3. It has to be 7. 7, 1, 8, 1, 3. Very simple question. What is X in the sequence 24, X, 12, 18, 36, 90? 24, X, 12, 18, 36, 90. Sometimes we think about plus, sometimes we think about multiplication. And so all of these numbers, the factors are linked to each other. And the numbers go bigger sooner. So I'm thinking product. And simple rule of thumb, into 2, into 2, into 2, it just become bigger. plus 2 plus 3 plus 2, the numbers stay close to each other. All of these are multiples of 6. These are all multiples of 12, so they're likely to be product. So 18 into 2 is this. 12 into 1.5 is this. 36 into 2.5 is this. 90 by 36 is 5 by 2, 2.5. Into 1.5 into 2 into 2.5. So quite possible into 1 into 0.5 into half into 1 into 1.5 into 2 into 2.5. That could be the sequence. 24 into 0.5 is half of 24. 12 into 1 into 1.5 into 2 into 2.5, or x should be 12. What is x in the sequence? 1, 3, 6, 11, 18, x. So now 1, 3, 6, 11, 18, x, 42. Gentle sequence, so maybe they're adding something. So plus 2, plus 3, plus 5, plus 7, 2, 3, 5, 7, beautiful prime numbers, plus 11, plus 13. 18 plus 11 is 29. 29 plus 13 is 42. Prime numbers, x should be 29. There are 7 places A, B, C, D, E, F and G in a city connected by various roads A, B, A, C, C, D, D, E, B, F, E, G and F, G. A is 6 kilometers to the south of B. So B and then A, so 6 kilometers. A is 10 kilometers to the west of C. C, 10 kilometers. D is 5 kilometers to the east of E. We don't have D and E yet. We'll come back to the statement. C is 6 kilometers north of D. Now we can bring back D is 5 kilometers east of E. F is 9 kilometers west of B. F is 12 kilometers north of G. Okay, now we can say, hey, AB is a road, AC is a road, DE is a road, CD is a road, DE is a road, BF is a road, EG is a road, and FG is a road. I put EG like this because we've not given a point of reference between E and G, but there is a road EG also. And these are all the locations. A person traveling from D to F through these routes, D to F through these routes, what is the distance covered by the person? 6 plus 10, 16, 22, 31. Or we could do this, this and this, it will be the same. As long as I am not repeating lengths, we can find this length. This 10 plus 9, 19, minus 5, this is 14. 14 plus 9, 19, 19 plus 12, 31. Both cases it is 31. 31 kilometers. In a certain code, if 64 is written as 343, 216 is written as 729, how is 512 written in that code? 64, I know this is 4 cube or 8 square or 2 power 6 powers. 343 is 7 cube. 216 is 6 cube. 729 is 9 cube, which is 3 power 6, 27 square. Different ways of writing these numbers. 512 is 8 cube. I can write as 2 power something and get from there. What is this is written, these two are linked, these two are linked. And through 4 cube is made 7 cube, 6 cube is made 9 cube. 4 cube plus 3 cube, 6 cube plus 3 cube. 512, 8 cube plus 3 cube should be 11 cube, which is 1331. Thank you for watching. Check out the course details here.